Good morning, friends. In the last two lectures, I think 2-3 lectures, we started brakes, and we studied some of the problems related with the brakes. But so main types of the problems, so means when the block brake acting, so that case we studied in the last lectures. So that's why today I am starting problems related means design of the brakes, that is of the block brakes. So please note down today's first problem. A single block brake with the torque capacity 45 Newton meter as shown in figure. The coefficient of friction is 0.3 and maximum pressure on brake lining is 1 Newton per mm square. The width of block is equal to its length calculate the actuating force the dimensions of the block third bit the resultant hinge pin reactions fourth bit the rate of heat generation if breakdown or rotates at 50 rpm So your figure given this distance 60, this distance 200, and this distance 450. So this is rotating likewise. So first I will draw free body diagram because this is rotating anti-clockwise, so that's why frictional force, so this is here acting is mu n, the normal force n, this is p. So that's why first we'll draw free body diagram of the levers. So here this is acting mu n. So during so this is breakdown mu n, and this is n. So that's why here's n upward, and this f downward. Now opposite of this frictional force, so this frictional force is opposite to this force, so this is mu n, and this distance is 60. Right? So that's why now by taking moments about pivot end. So first we will find out the intensity of the means how much is the force, means the first actuating force that is to be applied. Now directions, this is clockwise, this force anti-clockwise, did any mistake? Sorry, this is clockwise. So that's why this force, this is anti-clockwise. Here also we have to change the direction. Because this is opposite. Sorry. So this is mu n, and here This is mu n. So that's why here's now f into distance 200 plus 450, 650 plus, now this is also clockwise, mu n into 60, mu n into 60, and anti-clockwise force or moment, that is n into 200. And so these are the clockwise force and anti-clockwise force, n into 200. So here's two unknown, one is f and another is the n, but torque is given, torque equal to we can apply formula, we requires breakdown radius, so we require breakdown radius. So this is not given in the this may be right, this is given in the figure, so I forget that. So R 150. So this is first equation. Now by using torque equal to force multiplied by a radius, so that's why T equal to 45,000 multiplied by force n into 150, n equal to (300 newtons). So here's we have to frictional force multiplied by sorry. So this is again multiplied by 0.3. So that's why this is equal to 1000 Newton, because this is correct, mu n r, n equal to. Now by putting n values in this equation, f into 650 plus 0.3 into n 1000 multiplied by 60 equal to 1000 into 200. One thousand into 200. So first 650, 0.3 means 300 multiplied by 60, 1800 equal to divided by 650. 1 minute. So this is right. F equal to 280 newtons. F equal to 280 newtons. So this is the actuating force. Now the dimensions of the block, second bit. So here's pressure is given, second bit dimensions of the block. So here pressure equal to force divided by area. So any dimension 1 Newton per m square. Here is also 2 unknown. Width, inclinations we require, because this is first problems, because now 2 unknowns. So that's why we require 2 equation. So here this is given, the width of the block is equal to width so here's this is length equal to, here's we have to change because this is wrong. Width of the block is half of its length. So this is important. So that's why here length into B and relations B equal to L by 2. So L equal to 2B and this is 1 force 280 divided by 2B into B. So B equal to under root 140 again we did mistake here. This is F, we consider this is 280, this is not 280 because this is force. N equal to 1000. So that's why this is equal to 500. So B equal to 22.36 mm and length equal to length of the block, that is 44.72 mm. So this is second bit over. Now third bit, the hinge pin reaction. So hinge pin reactions means here this force is downward force and reactions here, this is upward N and frictional force, this is frictional force mu N. So N equal to 1000 and this is equal to 300. So that's why reactions means this is RH and RV, because RH equal to this is mu N equal to 300 Newton and RV equal to N minus F 1000 minus 280 equal to this is 720 Newton. So this is a reaction. No, the resultant. The resultant means R equal to RH square plus RV square. This is equal to RH equal to 300 square plus 720 square. So this is resultant. 300 square plus 720 square. This is 780 Newton. And last bit, fourth bit is the rate of the heat generations. So the rate of the heat generations equal to Hg equal to frictional force, I think mu N into average velocity. Frictional force multiplied by average velocity. And this is the formula. So that's why this is equal to pi dN divided by 60. V equal to formula. So V equal to, this is radius 150. So diameter equal to 300. So this is average velocity, means this is brought to 0, so that's why divided by 2. And this is pi d means 300 2 into, why this is divided by 60? Because this is average velocity. So we will complete this problem. After that we will check, because my camera is tilting. And divided by 60 by n. N is the RPM. N equal to 50. So this is pi multiplied by 300. So this is 392 meter per second divided by 1000. 0.392 V equal to 0.392 meter per second, because this is in EMM. So that's why mu into n. So Hg equal to formula 0.3 into 1000 multiplied by 392. So this is equal to 117 joule or 0.117 kilojoule. So this is correct. So I think you understand this design of the brake problems. So because of my camera tilting, so today I want to stop here because my mobile camera stand is not working properly. So I want to adjust that. So today we will stop here and we will continue remaining portions, remaining problems related with the block race in the next class. Thank you.